watch that video, the whole thing. But
The whole thing or not the whole thing?
Not the whole thing.
Oh, okay.
You can barely even hear us.
Oh, well, that's disappointing.
It is. So we can talk loud.
All right, Megan, make sure you remember. Oh, and Brooklyn. Brooklyn's out again. Or not again, but Brooklyn is also out. Make sure you guys remember to bring in your hall passes. We'll collect those later on this week. Okay. Chapter 7 review. Can you hear me okay?
Yeah.
Okay.
Because you're right next to the computer.
All right, I figured, but I mean,
We
we,
just scoot towards
We
your
died
desk.
laughing. Yeah. We just need to
Make a circle around your desk.
We moved the desks on Wednesday.
no.
We can post it like a talk show.
Yeah.
We can make podcasts. Yeah.
Oh my gosh. That is such a good idea.
That is a good idea.
After we all graduate, can we just have like a podcast?
So that would be so good.
No, they wouldn't.
We would at least have one, two.
All right, way back, beginning of the chapter, we talked about variation. The first type of variation was direct variation. Anyone remember the equation that goes with that?
X equals.
Oh wait, go ahead, Zane. Sorry, I didn't say her name. She didn't know I had looked at you. Yeah, were you gonna say that one, Bailey?
She said egg.
I was about to switch it though,
No.
and I was about to correct myself, and then she looked at me.
All right, so y equals ax, or if you also want to memorize a equals y over x. You did get that quiz back last week, so you have that to help you study as well. My goal is to hopefully give you back the other quizzes. Hopefully on Wednesday, I can make up some other versions for people that still need to make it up. So hopefully you'll be able to make that one up, and I'll get you the other quizzes back Wednesday, so you have those to study for. What other kind of variation do we have?
Inverse.
Inverse, indirect, we can call it either, I didn't care. But this book calls it inverse. Remember that equation?
Yes.
Go ahead, Ella. Okay.
Okay, is it y equals a over x?
Yep. And then if you want to memorize the a version, it's a equals yx. So y equals a over x, or a equals yx. There was a third one.
Z equals, or Y equals A.
It was z.
Z equals
Is it joint?
AXY.
Yes.
Yeah, so z equals axy, and that is joint. So joint variation, z equals axy. And I didn't really put the a one down there just because I just memorized it that way.
Gosh, you're dying over here. You okay?
Are you okay?
It's like the sharp in my throat.
Do you need to go get a drink or anything?
We can wait for you.
She doesn't want to use her whole
If you need to go run and get a drink, well, you can walk actually, but you can go. I won't make you use the
Do you
whole
need an
house.
escort to make sure you don't want to say?
Just leave the door open so you can get back in. Or you can call for help if you need it.
We'll give you 2 minutes. If you're not back, we'll come check for you.
Aren't the water fountains not open?
Definitely aren't. She's gonna stick her head under the.
Joe has attention for that.
No, she's.
Well,
gonna
maybe she'll
cover
go to
her
the
hands.
faucet.
Yeah.
Yeah. She can cover her
Okay, they just sit me down here with no faucet.
Well,
I didn't
hopefully she figures something out.
Threw away your flowers?
It was hanging
Bro.
over.
That was our flower.
That's so
Sorry.
disappointing.
Maybe you'll get me some for my birthday.
Oh,
No, let's not
we should
party.
all get bouquets for her.
All right, we're gonna do a little graphing. So we're gonna graph y equals -6 over x plus 4. We graph simple ones by hand. We graph more complex ones with the computer. You're not gonna have to graph with the computer. We'll get to that in a second. Would anyone like graph paper?
No, thanks.
I've already dived in.
Okay, so do you remember what these look like?
You know, it's like.
Gravel?
No, it can look as funky as you want.
So those are the ones we graph with the computer. Yes. Katie, what are you doing?
Oh, it's like this. They're like inverted.
Like they're like one of them's like this and the other one's like this.
Okay, I agree. Your first thing you were doing is you were
Look, okay. Axis.
So yes, there are two branches. But when you were first doing it, you were like doing a whole little dance.
That's what it is.
Okay, so
Continue.
all right, so there are two branches. You're gonna have one branch and another branch. They're gonna be opposite of each other. So they might be two over here, or they might be two over here. Does anyone remember what that's called?
I can definitely see that.
Quadrants. That would have been easier.
So they're in two different quadrants, yes. Hyperbola. So close. So let's put graph
Out of the faucet.
On the faucet.
is a hyperbola. And there are two
Oh,
branches.
is anyone else in there?
Leave her alone.
I'm just kidding.
She's surviving now. So the graph is a hyperbola. There are two branches. There's also two what?
Asymptotes.
Asymptotes.
Oh yeah, you stole my last one from me.
So two branches as well as two asymptotes. All right, so that was the first thing we actually came up with when we went to go and graph these. We identified the asymptotes. We identified the vertical asymptote and the horizontal asymptote. Do you remember how we did that? We pulled it right out of this function.
-4
No.
is the vertical, and horizontal is 0.
Mm.
Okay.
0 is
X.
vertical, -4 is horizontal.
So we look here first. That's going to be our vertical.
Yeah.
Vertical, is that X or Y?
Y. X.
X. Vertical lines are X equals, and I need to see that with it. So X equals 0. Horizontal are Y equals lines. And that's this number. And we don't change the sign. Now, the one underneath we usually do, but there's no number there, so I didn't get to change the sign. So Y equals 4. How many numbers am I going to plot?
6.
Yeah, I like to make two separate tables. Some of you just make one big one. That's up to you. I need numbers on the left and the right of my vertical asymptote. Well, here's my vertical asymptote, 0. Actually, I want a bigger graph. So here's my vertical asymptote. I want numbers on the left and the right. So numbers on the left would be -1, 0. Nope. Did it last period too. -1, -2, -3. Numbers on the right would be 1, 2, and 3. And then I'm just going to plug all those in. Well, I saved what we did last period. -1 is 10. -2 is 7. -3 is 6. 1 is -2. 2 is 1. 3 is 2. I'm going to put that other asymptote in there. And you want to make sure you never cross the asymptotes. And so this is what I was saying that we were all upset that Megan and Brooklyn couldn't see. Your branches are either going to be here or they're going to be here. They're going to be opposite of each other, and they shouldn't cross the asymptotes. So I'll see where they end up. So they're definitely opposite of each other, and they're not crossing those asymptotes.
I don't like football.
Honestly, it feels like when you go outside without your dog and they're just watching, you have so much fun out there.
I do feel like that. Hi, Charlie.
Don't call him over here.
Are you?
Wait a minute.
I'm really so stupid.
You're not. What happened?
It's an emotional content.
Are we okay on this?
Yeah.
Bailey, let me know when you're okay.
I don't understand what I'm doing.
Okay, do you want me to come look at it?
No, I'm just having a brain fart. I can't. Oh, never mind.
So you're good?
Yeah.
Okay.
Being super stupid.
You're good now though.
I believe so, yeah.
Alright, so let's look at this one. We won't graph this one, let's just do the two intercepts. So we've got y equals 2 over x plus 2 and then minus 3. So we're just going to do the vertical asymptote and the horizontal asymptote. We won't worry about graphing. So vertical asymptote, I'm going to need x equals. Horizontal asymptote, I'm going to need y equals. Vertical is going to be x equals. Good, change that sign. So I wanted to see that because we didn't see where we had to switch. Horizontal is going to be y equals. Good. And then I'd make my two tables or my one big table. I'd plot those. All right, so then the other type of graphing we did, we used the computers, all that. But before we did the computers, we identified the x-intercepts, the vertical asymptotes, the horizontal asymptotes. And we did that using this green sheet. You may want to pull that out because you are going to need the information on this green sheet.
We could memorize that for the test.
Yep. Now, this is the same thing last period said, but really, it's not that much to memorize. You just need to know that you. Don't look at me like that. You really just need to know that you kind of go in order. You need to know the x-intercepts. You need to know the vertical asymptotes, the horizontal asymptotes. Now, you need to memorize a little bit for the horizontal asymptotes, but not a lot.
Why do I
don't know how my brain works. I can't remember.
All right, so it's going to say, the directions are going to say, state the characteristics. Go ahead and write down y equals 6 over x squared minus 1.
That's how it's going to be on a test.
Yep. I won't have that part written out for you, but it's going to say state the characteristics. It will look the same on the review sheet. I'm pretty sure in the directions I go in order like this, though. I think I say x-intercepts, vertical asymptotes, horizontal asymptotes. So we just go in order. It's the order you read the fraction. You read the top, the bottom, and then you compare the two things together. So the top, when I say I deal with the top, I set the top equal to 0. Well, 6 equal to 0. Does that make sense?
No.
No. So what do you think I put?
No.
Yeah, I put no or none. Make sure you don't put 0 because that could get confused with x being 0. So no or none would be acceptable. Not equal there. So I work my way. I did the top, now I look at the bottom. So I'm going to do x squared minus 1 equals 0. Well, you could factor, you could do the square root method. That's up to you. I'm going to do the square root method. Just don't forget plus or minus. So x equals plus or minus 1. Fine to just label it VA. So those are your vertical asymptotes. Now, horizontal asymptotes, you're comparing the top and the bottom. What are you comparing about the top and the bottom?
Degree.
The degree. Well, the degree is the exponent. What's the exponent on the top?
1.
It's 0. If there's not an x, the degree is 0. What's the degree on the bottom?
2.
And so then I compare it. I read it top to bottom. So 0 is less than 2.
No.
So, but this is what I have to memorize. So that's on the back. So I flip it over.
No horizontal.
It's 0.
So when I look at the back here, when I go less than, it's the first case. So it's 0. So this is when I say y equals 0 for my horizontal asymptote.
Can we get like a little
Nope.
note on it?
Nope. You do not have a lot to memorize here. You have direct, inverse, joint variation, and you have this. The rest of it, it's problems. That is not a lot to memorize. Wait till you get to memorize the unit circle next year. That's a lot to memorize. What about in chemistry, where you have to memorize the whole periodic table?
You don't have to memorize that.
You don't have to memorize that?
You memorize some, but like
And
then
it
we
all
forgot it
went
right
away.
after.
Well, forget this right after. Memorize it for a day.
I didn't even get that part for a day.
All right, here we go. I'm going to pretend we don't have this. I'm not giving this part to you. So we've just got y equals 3x squared plus 6x over x squared plus 5x minus 6.
My chest is tight.
I'm sorry. All right, so what do I start with?
X-Intercepts.
So X-Intercepts, and I look at what part of the fraction? The top. I'm even going to factor maybe as I go down to this line. So I'm going to pull out a GCF, 3x, leaves me with x plus 2. So that means x equals 0, x equals negative 2. Those are my X-Intercepts. Then I go on to the vertical asymptotes. I look at what part of the fraction? The bottom. That factors into x plus 6, x minus 1. X equals negative 6, x equals 1. All right, this requires a little bit of thinking, a little bit of memorizing. The degrees. Both of them. This is the one that I think is the trickiest, is when the degrees are equal. When the degrees are equal,
You're logged by the coefficients.
I gotta go to the leading coefficient. This leading coefficient over this leading coefficient. Well, it's just the top over the bottom. So y equals 3 over 1. Well, I'm just going to go ahead and reduce that. Y equals 3. Yeah. There I go.
If we go out in this Kansas class, I'm gonna find your window.
Seriously, what would you do?
What period is it?
6.
It's my plan.
Oh, yes,
See
we
if your
definitely
window
are.
a jar. A jar.
All right, I want to do, we're not going to have time to do both. Let's just, I'll remember. We'll just say both of these for Wednesday. I want to do an add and subtract, and I want to do a multiply. But let me just talk about it in case you start working on this tomorrow or even tonight. If you are adding and subtracting, so we'll do this on Wednesday, but if you're adding and subtracting, what do you need?
You need the same
Common
Common denominator. When you go and you multiply and you get that common denominator, do you lose the denominator?
No.
No, because it's not,
Multiplication.
no,
Equal.
because it's not equal to. So if you're just adding or subtracting, keep the denominator. When you're solving, when it's an equation, that's when you lose the denominators. So that's always tricky when we get to this test and people will say, well, when do I lose the denominator? When do I not? The review sheet is not due, but you have it so you can start working on it. I don't think I've posted the review sheet yet. I'll try and get that up today. If not today, I'll definitely put it up tomorrow. Wednesday, we'll go over these two problems, and then we'll have the rest of the time to work. Assuming it is supposed to be nice, assuming it is nice, we probably will go outside for part of that time to work outside, not to do this crazy thing and go out and play football. We're gonna get some work done out there.
Lay the line down.
Yes.